Right, last question I'm going to do now. Right, with a question like this, people sometimes don't read the question. I can imagine some people just timesing all three numbers to get the volume, or some people might end up working at the surface area without really understanding what the question is about. So let's find out what the question is about. The cuboid and the cube below are placed on the floor. Okay, so these two things are on a floor. So you can imagine, if I just draw this a bit better, hold on. So imagine that that's the floor, okay? And obviously these two boxes are exerting pressure on the floor. The cuboid has a weight of 60 newtons. The cube has a weight of 40 newtons. Which one exerts greater pressure on the ground? So it is a pressure question, right? Not asking for the volume of the cuboid or the surface area. Now you're going to understand what part, it's talking about the ground here. So what part of these shapes are in contact with the ground? It's obviously the bottom face, isn't it? The bottom part of each of these shapes is in contact with the ground. That's what matters. Right, since it's a pressure question, we need that formula again. Force, pressure, area. Right, let's do this one for the cuboid. Right, this is the calculation for the cuboid I'm doing. The big one, yeah? Force is 60 newtons. Right, area. Right, it's not asking for the volume or the surface area, just the area that's in contact with the ground. Right, it's this bit here. That's what's in contact with the ground. So I need to work out the area of that rectangle, this rectangle over here. Area of the rectangle is 8 times 3, 24 centimeters squared. So that's your area, 24 centimeters squared. So all that force is acting on this little area. So I'm going to use my calculator then. 60 divided by 24, I get 2.5. The pressure is 2.5 newtons. Look at the units. Newtons per, not meter squared anymore, it's centimeter squared. Right, now I'm going to do the same calculation for the cube. It is a cube. Right, all the sides are the same size, right? The height, the width, the length, etc. Right, so obviously this side is 4 centimeters as well. The bit that's in contact with the ground over there, it's here. Right, that's just a square. The area of that is 4 times 4, 16 centimeters squared is what I put here, 16 centimeters squared, and the force is acting on that is 40 newtons. So therefore, the pressure is 40 divided by 16. 40 divided by 16. I'll get 2.5 newtons per centimeter squared. Right, it looks like both shapes, even though they're different sizes, different weights, are producing the same amount of pressure on the ground, right? Same amount of pressure. And I've got my calculations to back me up. Right, why is it that a needle, imagine this is the needle, can pierce most types of material, can go through it just by applying a bit of force? Well, it's to do with the tip of the needle, the tip. The tip is very tiny, it's like a tiny little dot, even smaller than that dot you see on the screen. It's got a very, very small area. Right. So if I just demonstrate this with some kind of calculation, let me just show you. Right, let's suppose I apply just a couple of newtons, right, not much. You don't need to apply too much force to pierce a material. Let's say we apply 2 newtons. Let's suppose, right, just making this up, let's suppose the surface, the area of the tip happens to be very, very small. Let's say 0.0001 centimeters squared. Probably a lot less than that. If I do the maths behind that now, so if I just do 2 divided by 0.0001, I'll get 20,000 newtons per centimeter squared. That's a huge amount of pressure. That needle could pierce most types of material. What you can see here is a monk throwing a needle towards a glass, right? And he's able to pierce that glass using just the needle. Had he thrown anything blunt, he would have smashed the glass.